Most people who use software every day don't think about bugs. They don't think about what can happen if the software that they depend upon suddenly is less secure.
So today, we're diving into an AI initiative that's really flipping the script on cybersecurity. It's a project called Glasswing, and it's all about giving the good guys a much-needed head start in a race they absolutely cannot afford to lose.
These models have capabilities which are raising the bar from a cybersecurity point of view with their ability to help defenders as well as potentially help adversaries.
Let me ask you a question. What if a single, tiny, hidden flaw in a piece of code could bring down huge parts of the internet? Yeah, it sounds like something out of a sci-fi movie, right? But the thing is, that threat is way more real than you might think. In fact, it's the very problem we're up against right now. Here's the fundamental truth. Our entire modern world, everything runs on software. And every single piece of that software, from the apps on your phone to the massive systems controlling our power grids, has always had hidden imperfections, bugs, little mistakes hiding in the code.
We haven't trained it specifically to be good at cyber. We trained it to be good at code, but as a side effect of being good at code, it's also good at cyber.
Okay, so before we get to the solution, it's really important we wrap our heads around the sheer scale of the problem. We've got to start with these invisible flaws that are basically woven into the fabric of our digital lives.
Now, when we say flaw, what we really mean is a vulnerability. It's just a fancy word for a weak spot in the code. Think of it like a crack in a castle's wall, a weak point that an attacker can use to get in and cause some serious trouble.
And here's where a tiny problem can blow up into a global crisis. It all starts with one small mistake in a piece of shared code, something developers call a library. Then hundreds, sometimes thousands of other products use that same library to build their own software. And boom, just like that, that one little flaw gets copied and pasted and is now hidden everywhere.
It has the ability to chain together vulnerabilities. So what this means is you find two vulnerabilities, either of which doesn't really get you very much independently. But this model is able to create exploits out of 3, 4, sometimes 5 vulnerabilities that in sequence give you some kind of very sophisticated end outcome.
For decades, finding these flaws has been this slow, manual game of cat and mouse between human good guys and human bad guys. But now, a powerful new player has stepped onto the field and is changing the rules of the game completely. And that player, of course, is artificial intelligence.
I mean, think about it for a second. It makes perfect sense, right? We're building these incredible AIs that can write code just as well as the best human developers. But here's the catch. If an AI is smart enough to write that code, it's also smart enough to find the hidden mistakes inside it.
And this right here is the heart of the dilemma. It's a total double-edged sword. For defenders, AI is an amazing tool. It can find bugs way faster and help us fix them. But for adversaries, that exact same power can be used to find those weak spots, automate massive attacks, and even dream up entirely new kinds of malware.
And we think that this model can do this really well because we notice that this model is very autonomous. It's just generally better at pursuing really long-range tasks.
And listen, this isn't some far-off future problem. It's happening right now. In fact, researchers at the AI company Anthropic weren't even looking for a cybersecurity tool. But with their new model, they kind of accidentally created one.
So this model is called Claude Mythos Preview. What's so wild about it is that it was never explicitly trained to be a cyber defender. Nope, it was just trained to be exceptionally good at understanding and writing code. But it turned out that as a side effect of that skill, it also became as good at finding vulnerabilities as a professional human security researcher.
But this AI didn't just find single isolated bugs. It showed off a much more sophisticated and frankly dangerous ability. It could take seemingly harmless little flaws and chain them together to create something seriously powerful.
So how does this chaining actually work? Well, it's kind of like finding 3 different keys that don't seem to open any important doors. But the AI figures out that if you use those keys in a very specific sequence, you can unlock the main vault. It turns 3 small, low-impact problems into one big, highly dangerous security breach. It's a complete game changer.
And by giving these software developers advanced tools before anyone else, it gives all of us a collective head start.
So when the researchers saw what this thing could do, they knew they couldn't just release this model into the wild. That could be a disaster. They had to get ahead of the problem. And that's exactly why they launched a proactive defense initiative.
And that initiative is Project Glasswing. The mission is really simple, but it's also profound. Put these powerful AI tools into the hands of the good guys first. By giving software defenders access before the bad guys can develop similar tools, it gives all of us a collective head start.
So, did it work? You bet it did. The results were immediate, and they were powerful. Just look at this number.
27 years. That's how long a critical bug was hiding in the code of OpenBSD, which is an operating system that helps run a huge part of the internet. A human expert hadn't spotted it in nearly 3 decades, but the AI did, and this wasn't a minor flaw. It could allow pretty much anyone to crash internet servers.
And that wasn't a one-off, not at all. In a Linux operating system, the AI found vulnerabilities that could let a totally normal user take over a machine as the full administrator. But crucially, for every single bug it found, the project partners responsibly notified the people in charge, who then fixed the issues and sent out patches, making the software safer for everyone.
And hey, you don't just have to take my word for it. Check out what one of the security researchers who participated in the project had to say. The sheer scale and speed of this AI-assisted discovery is it's on a whole other level.
It is essential that we come together and work together across industry to help build better defensive capabilities.
So what's the big picture here? We are clearly entering a brand new era. This isn't just about finding individual bugs anymore. This is about a fundamental race to secure our entire digital future.
And this matters to every single one of us. You know, there's a saying in the tech world that software has eaten the world, and it's absolutely true. Our daily lives, our financial systems, our critical infrastructure, it all runs on code. And that means cybersecurity is no longer some niche technical field. It is the security of our society.
The path forward is going to require a whole new way of thinking. No single company, no single government can solve this alone. It's going to take a massive collaborative effort, with everyone from industry to government working together to defend our shared digital infrastructure. And this isn't a short-term project. This is the work of months and maybe even years to come.
What this all really boils down to is that AI is dramatically escalating the cybersecurity arms race for both the attackers and the defenders. The tools are getting more powerful at a mind-boggling rate. So the only question that remains is a simple one. Are we ready to run faster?